Okay, so we've seen in the previous video that if we have a system of two equations, we could also look at this one as just a matrix multiplication. The thing in front of the xy is called the coefficient matrix. So these are the numbers in front of the x and in front of the y. So if we look at this system, then how can we find the inverse matrix useful to solve this set of equations? Okay, let's give that one a try. So if we have this matrix, coefficient matrix 1, minus 3, 2, minus 5, we could calculate the inverse matrix. So let's just call this matrix A, then the inverse matrix would be A minus 1. Okay, if you remember correctly, then A minus 1 times A would give us the unity matrix. And if we have the unity matrix, so this one would be 1, 0, 0, 1, and we multiply that with xy, nothing will change. So multiplying a unity matrix with xy would just give us xy. 1 times x plus 0 times y. For the second one, 0 times x plus 1 times y. So if I multiply on the left with the inverse matrix, the only thing which will remain is the xy. So that means if I do this, a minus 1 times a times xy, and I have the same multiplication on the right, a minus 1 times 3, 2, at the solution part, then on the left I have nothing left. So this would result in xy being a minus 1 times 3, 2. So as a miracle, if we just calculate the inverse matrix with the small trick, making the determinant, shoving them around, then the result would give me a minus 1 times 3, 2 would give me a solution of this set of equations. So we don't have to do substitution or elimination or anything anymore. Just calculate inverse matrix, multiply it with the solution part, and we're done. Okay, if we look at this set of equations, so 3x minus 2y equals 4, minus 6x plus 4y equals 3, and we'd like to solve this one, then we start with our small trick, and we calculate the inverse matrix. So let's start by calculating the determinant. So the determinant of 3 minus 2 minus 6, 4, would be 3 times 4, 12, minus 2 minus 6, so that would give us minus 12, would give us 0. Ah, that's a pity, because now I have a set of equations where I cannot calculate the inverse matrix for. Can you imagine what that means? So let's try to figure this out. So apparently I cannot find an inverse matrix. Does that say something about these two equations, these two lines? Well, if we look again at our basic line equation, and we have to calculate a gradient and an intercept, then this would give us minus 2y being 4 minus 3x. So that would give us minus y being, or plus y, let's do that immediately, being minus 3x divided by minus 2. So that would be 3 divided by 2 times x. Minus 4 divided by 2 would be 2. Okay, if we look at the second one, then we have 4y being 3 plus 6x. So that means y would be 6 divided by 4, which is 3 divided by 2x, plus 3 divided by 4. Ah, okay. So, do you see what's happening? We have two lines with the same gradient. So that means that these lines are parallel lines. So apparently, if the determinant is 0, then the lines are in parallel and we cannot find the solution. Or maybe they are exactly the same, and then we would see that the intercepts are the same as well, and then we have infinite solutions. So we can conclude, if the determinant of a matrix is 0, then the inverse matrix does not exist, and that means that the two lines have the same gradient. They're parallel or they're exactly the same. So this concludes our part of the linear algebra. Please look at the exercises again on SharePoint and join me in our meeting if you have any questions.